Hi, this is an example problem from Chapter 12 on fluid flow. Pause for a moment and read the question. So this is one that you're probably familiar with if you ever used a hose to wash anything or water anything. We know that if you constrict the opening of the hose with your thumb, that will make the water come out of the hose at a faster speed. So we're going to look at that here. We've been told what the cross-sectional area of the hose is here, right? So when the hose is opened, unconstricted, it's got a cross-sectional area which has a certain value, right? And over here, we're going to obstruct that with 3/4 of our thumb, so only 1/4 is left. This thing has only got 1/4 of the area that you have when it's unobstructed. Part A, we're going to calculate what is the volume flow rate of water through the hose. Well, Q is what we use for the variable volume flow rate. And we know that according to the equation here, Q is equal to the area, that's the area through which the fluid is flowing, multiplied by V, the fluid speed. And in this problem, well, we're given a few things here. We're given the area of the hose, 2.85 times 10 to the -4th meters per second squared, right? But then we're given some more information here. To wash your car, you fill a bucket that has a certain volume here, and it takes you a certain amount of time to fill that bucket, right? So in terms of thinking about Q as being the area times the speed of flow, well, we don't know what the speed is. That's okay, actually, because Q can also be thought of, what are the units of Q here? Q is volume, meters cubed per second, volume flow rate. Q is also, by definition, equal to the amount of volume that flows in a given amount of time. Change in volume per change of time. In that case, we do have the change in volume here. The amount to fill the bucket up, that is equal to 8.00 times 10 to the -3rd meters cubed. That's the volume of the bucket, about 2 gallons. And that is filled in a time of 30 seconds. That's going to give us the flow rate. That's going to be equal to 2.67 times 10 to the -4th meters cubed volume of water per second that flows through the cross-sectional area. All right, let's look at part B. Find the speed of the water leaving the hose, part B, while filling the bucket with the hose unobstructed. So that's going to be the unobstructed area A that's given, and using the equation here for volume flow rate related to area, cross-sectional area, and speed, we can solve for that speed here. So the speed V, right, I need to divide Q by A, the area of the hose. And so we know what Q is here, 2.67 times 10 to the -4th meters cubed per second. Divide by the area unobstructed, this one, 2.85 times 10 to the -4th meters squared. And that gives us a speed. You can see that that's going to cancel those, and 2 of those gives us the meters per second, and the speed comes out to be equal to 0.936 meters per second. All right, in part C, we're going to ask, as you cover the opening 3/4 of the way with your thumb, how does the speed change? Well, in this case, we can use the same equation again, and Q, the volume flow rate, that's the same. The same amount of water has got to be leaving that hose per unit time. However, the area has now changed, right? Instead of A, now we've got 1/4 A. So if I write this as A over 4, we can see that this is actually going to come out to be equal to 4 times Q over A. And Q over A was the original value that we just got here. So this is going to be equal to 4 times 0.936 meters per second, which gives us a speed 3.74 meters per second. So by closing the area, reducing it to 1/4 the size, we can get the water out with 4 times as much speed.